Picture a dimly lit machine shop in some forgotten corner of America, the air thick with the tang of cutting oil and hot metal. There she sits, a 1938 Bridgeport Series I vertical milling machine. Her gray cast iron frame scarred by 8 decades of abuse, dents from flying chips, paint flaked off like old skin, quill handle worn smooth by calloused hands. The operator cranks the wheel, and the table glides under the spinning endmill with a low, resonant growl. He touches off on a raw steel block, and out comes a part holding tolerances to 1/1000th of an inch. Perfect. Flawless. After 80 years of non-stop punishment, she cuts true. Now look at her modern cousin, a gleaming $120,000 Haas VF2 CNC mill, fresh from the factory floor. Servo motors whine, screens flicker with CAD files, fans hum to cool the electronics. 6 months in, a power surge fries the controller. Ball screws whine from inadequate lubrication, warping the ways. Spindle bearing seize under thermal expansion because the lightweight aluminum frame can't take the heat. By year 10, it's scrap. Frame twisted, servos shot, the whole beast retired to a dumpster, while the Bridgeport beside it laughs and keeps milling. How does this hulking relic from the age of slide rules outlive a computer-guided marvel by a factor of 8? It's not luck. It's engineering born from brute necessity, a paradox that burns me up. We traded heavy metal for fragile silicon, and now we're paying the price. Step back to the desperate 1930s. The Great Depression had gutted America's industrial heartland. Factories stood silent, bread lines snaked through cities, and skilled machinists scavenged scrap for beer money. Bridgeport, Connecticut, heart of the brass and tool-making trade, was a ghost town of idle lathes. Then came the thunder from Europe. Hitler's panzers rolled into Poland in '39, Japan's carriers prowled the Pacific, and suddenly the U.S. faced a reckoning. We weren't ready. Our arsenal was a joke. Outdated rifles, biplanes that couldn't climb, tanks with pea-shooter guns. Congress screamed for production. Millions of gears, bushings, propeller hubs, shell casings. Overnight, the War Department issued contracts that demanded precision machining on a scale never seen. Failure wasn't an option. It was do or die. Invade us? Not if every factory could churn out parts around the clock. Enter Rudolf Banno and Magnus Wallstrom, 2 Swedish immigrant engineers holed up in a rented garage on Fairfield Avenue. They'd tinkered with horizontal mills, but the war cried out for something vertical. Faster setups for intricate war work. No time for complexity. In 1938, they poured their savings into a design that could be built fast, run by any grease monkey with a steady hand, and hammer out tolerances tighter than a drumhead. The Bridgeport Series I was born, not a delicate toy, but a 2,200-pound behemoth that could take a beating and dish one out. By 1941, Pearl Harbor lit the fuse. Bridgeport machines ramped up, shipping thousands to arsenals from Springfield to Rock Island. These mills machined the guts of B-17 bombers, M1 Garands, Liberty ship engines. One glitch, one undersized gear, and a tank throws a track in Normandy. Lives hung on every pass of the cutter. The crisis peaked in 42-43. Raw materials rationed, steel diverted to hulls and tanks. Labor shortages meant green kids and women straight from farms learning to read micrometers. Power grids strained under blackout orders. Yet those Bridgeports ran 24/7, 3 shifts, spitting sparks into the blackout. They bridged the gap from Depression's scrap heap to arsenal of democracy. Without them, D-Day might have stalled on Omaha Beach with faulty landing gear. This wasn't engineering for peacetime profit. It was forged in the fire of total war, where a machine's weakness meant a soldier's grave. But what made her tick? The secret sauce lay in the frame itself. Cast from mehanite, a dense vibration-damping iron alloy that starts as molten metal at 2,800 degrees Fahrenheit, poured into a massive sand mold weighing half a ton. No welds, no composites. One solid pour, annealed slow in coke-fired ovens to relieve stresses that could warp a spindle over time. The bed alone tips the scales at 1,500 pounds, with walls 2 inches thick, giving it a natural frequency that shrugs off harmonic vibrations like a boulder ignores a pebble. Dovetail ways, hand-scraped to optical flatness. Each slide mated to its mate with Prussian blue, scraped 1,000 times until blue transfers vanished, creating oil pockets that self-lubricate under pressure. Feel the physics. Saddle the table with a 500-pound workpiece, crank the rapid traverse. Inertia fights back, but the mass damps it. No chatter marks scarring your finish. Spindle, a tapered roller bearing setup preloaded to 10,000 pounds, chucking a 2-inch face mill at 1/500 RPM. Heat builds. Spindle hits 200 degrees, but the iron dissipates it, expanding uniformly without binding. Safety factor? Overbuilt by 400%. Modern mills run at 100% nominal. Overload the Bridgeport, and she flexes like a prizefighter's jaw, then snaps back true. No sensors to babysit, no code to crash. Pure mechanical honesty. Workers paid in blood for that reliability. Imagine the night shift. 100 degrees Fahrenheit inside from motor heat. Oil mist coating your lungs like fog in a steel jungle. Hands raw from feeding stock, ears ringing from the cutter's scream. One slip, flesh meets 20 horsepower spin. And it's amputation city, no laser surgery back then. Decompression bends from compressed air tools? Nah, just caisson disease knocking you flat. Yet they ran her hard, because quitting meant the Jerry's or Nips won. That human toll etched into every over-travel stop, every guarded belt. By war's end, over 250,000 Bridgeports had clawed America to victory. But the real test waited decades ahead. Fast forward to the Korean War, and those Bridgeports were back in the saddle, chewing through jet engine turbine blades and recoilless rifle mounts. No rebuilds needed, just a fresh belt, a squirt of whey oil, and they hummed on. Vietnam chewed them harder. Agent Orange rotors, Huey transmission gears, all machined in sweltering arsenals where coolant evaporated before it hit the chip pan. Still, they held tolerances. Zero drift. By the 1970s, the oil crisis slammed civilian shops. Plants idled. But the mills kept turning prototype dies for Detroit's last gasp of muscle cars, their spindles unflinching under overloaded collets. The 1980s brought the Japanese invasion. Toyotas flooding lots, killing American auto jobs. Bridgeports and shuttered factories gathered dust, then got dragged to back-alley job shops for survival work. Custom forks for Caterpillar loaders, repair parts for Conrail diesels. Flooded basements from Hurricane Hugo in '89? Operators winched them out, dried the ways with torches, and back to work. No fried circuits. The 1990s NAFTA gut punch sent more to scrapyards, but survivors pivoted to aerospace overflow, F-22 fittings machined on wartime castings that laughed at the flood of cheap imports. Come the 2000s and the real abuse piled on. Chinese knockoffs flooded eBay, but the old girls soldiered in R&D labs, prototyping Mars rover gears at JPL, holding 0.005-inch flats where million-dollar Hercos balked. The 2008 crash. Shops went belly up, mills orphaned in foreclosed warehouses, exposed to Michigan winters, rust creeping like ivy. Yet a rebuild shop in Ohio reports pulling one from a snowdrift, table seized solid. But after 3 days of heat and scraping, she milled AR-15 receivers smoother than factory. 80 years in, and they're still the backbone of American gunsmithing, turning out 1911 slides that win matches. Now stack that against the modern fragility. Take the Haas VF2 I mentioned. $120,000 ticket, promised 15,000-hour spindle life. Real world? A Midwestern tool shop logs 4,200 hours before the first failure. Rain sneaks through the enclosure during a storm, shorts the encoder feedback. Spindle crashes into the table, $8,000 rebuild. Ball screws, those precision ground wonders, demand synthetic grease changed every 2,000 hours, or they pit from micro-vibration, slopping the axis by 0.03 inches. Owner skips one cycle, weighs gall, frame twists 0.0010 inches out of true. No mass to dampen it, just lightweight castings and epoxy granite pretending to be rigid. Worse, the software. Fanic control, Cutting edge in 2015, bricks on a Windows update gone wrong. CAD file corrupts mid-job, zeros the tool table. John Deere learned this the hard way with their 8R tractors. Software patch in 2022 locked out farmers after 1,500 hours unless dealer approved, stranding $500,000 rigs in fields while yields rotted. Bridgeport? No OS to glitch, no subscription for firmware. Crank the wheel, it goes. Thermal growth? That mehanite expands predictably, 0.00006 inches per degree, while the Haas aluminum frame warps 0.002 per degree, binding the Z-axis at 150 degrees Fahrenheit, common in summer shops without $10,000 climate control. Look at the 2021 Surfside condo collapse in Florida. Partial cause: corroded rebar and thin, high-strength concrete slabs chasing lightweight efficiency. Echoes the mills. Modern CNCs shave weight for faster shipping, using hollow extrusions over solid iron. Result? First overload chatters the finish. Harmonics amplify to spindle failure. Boeing's 737 MAX, software overrides flew 346 souls into the sea, trusting code over physics. Bridgeport's endured because they embodied redundancy. 400% safety margin meant a dropped vise didn't total her. It dented and done. So why'd we ditch this? Profit, pure and simple. Post-war, Bridgeport costs ballooned. $12,000 in $1960 for labor-intensive casting and scraping. Enter CNC pioneers like Yamazaki Mazak in the 70s. Numerically controlled, one operator runs 10 machines, slashing payroll 80%. By 1990, regulations piled on. OSHA mandated interlocks, enclosures, sensors adding $20,000 per unit. EPA choked foundries with VOC scrubbers for sand molds. Mehanite pores vanished stateside. Unions priced hand scraping out, 45-hour verse robots at $15 amortized. Then planned obsolescence sealed it. Fanuc & Siemens bacon proprietary chips that fail after 7 years, forcing $50,000 upgrades. Haas pushes super-fast rapids, but skimps on bearings. MTBF drops to 3,000 hours. Shareholders demand quarterly spikes, so frames lighten 40%, rigidity tanks. Safety theater? Yeah. Guards everywhere, but ignore the root. Mass defeats vibration better than any airbag. We chased speed and margins, forgot inertia rules. A 2,200-pound mill absorbs punishment. A 4,000-pound CNC dances itself to death. Decades of abuse, wars, recessions, floods, and the Bridgeport endures, while her digital heirs limp to the landfill by decade's end. She's a testament to overbuilding without apology, the kind of iron we swore off for spreadsheets and silicon dreams. But as supply chains snap and chips starve, those gray relics whisper, maybe brute force wasn't so dumb after all. The legacy waits, still spinning in garages where real work gets done. By war's end in 1945, those Bridgeports stood scarred but unbowed, their tables slick with the residue of 1 million wartime cuts. Over 250,000 units had poured out of Connecticut foundries, machining the sinews of victory. From the helical gears in Sherman tank transmissions to the propeller shafts of P-51 Mustangs. No victory parades for the machines, though. They got shoved back into production lines for tractors, refrigerators, and the post-war boom's endless hunger for precision parts. The real proving ground unfolded over the next half-century. A gauntlet of wars, economic gut punches, and environmental hammer blows that would pulverize lesser iron. Korea erupted in 1950, and those same mills chewed through titanium alloys for F-86 Sabre jet flaps, their spindles whining at 2,000 RPM under floodlights in Springfield Armory basements. No fancy coolant pumps, just pans of soluble oil sloshed by hand, evaporating in 110-degree heat waves. Operators piled on 600-pound fixtures for recoilless rifle barrels, the mass transferring torque without a quiver, holding concentricity to 0.0002 inches across 36-inch lengths. By armistice, they'd logged 10,000 hours apiece, ways barely worn, because that dense casting absorbed the chatter that would chatter modern linear guides to ruin. Vietnam dragged them deeper into hell. Arsenals in Rock Island sweltered through monsoons, humidity rusting unguarded tables overnight. Yet machinists torched off the corrosion, re-scraped the mating surfaces with Arkansas stones, and cut Huey helicopter swash plates, complex curves demanding zero backlash. One Bridgeport and a Detroit overflow shop machined 5,000 M16 bolt carrier groups in 1968 alone. The quill-dropping heavy face mills into AR-15 forgings without thermal bind, even as ambient temps hit 130 degrees from banked motors. Floods from Hurricane Camille in '69 submerged a fleet in Mississippi. Salvagers winched them free, baked the oil out, and they milled again, tolerances intact. The 1970s oil embargo hit like a sledge. Factories throttled back, but surviving Bridgeports pivoted to survival jobs. Custom bushings for Ford Pinto axles, die sets for Zenith TVs. In shuttered GM plants, they sat idle through Rust Belt winters. Castings cracking superficially from freeze-thaw cycles, yet internals stayed true. No microfractures propagating like in today's brittle castings. 80s recession? Japanese CNCs undercut prices, but the old mills found refuge in tool rooms, hand-finishing prototype molds for Chrysler's K-cars, their overarm support steady under unbalanced cutters that would vibrate a VF2's frame into misalignment. By the 90s, globalization's tsunami washed them into garages and vocational shops. NAFTA idled factories, but one Bridgeport survivor in a Pennsylvania scrapyard, dragged from a flooded basement post-Hurricane Floyd, endured 3 days of oven drying at 400 degrees before milling diesel injector bodies for Cummins rebuilds. Aerospace contractors snuck them onto overflow contracts. F-117 stealth fighter pylons, machined to 0.001-inch flats where titanium chips flew like shrapnel. The 2000s tested their metal further. Post-9/11 defense surge loaded them with Black Hawk gearbox housings, spindles pushing 3,000 RPM on inconel, heat blooming to 250 degrees, but dissipating evenly through the massive bed. The 2008 financial implosion orphaned hundreds in foreclosed warehouses from Detroit to LA, exposed to blizzards and vermin. A Michigan restorer hauled one from a foot of snowmelt. Table frozen solid, but after lap scraping and lapping, it cut 7275 aluminum landing gear prototypes for drone firms, deflection under 500 pounds load measuring a mere 0.05 inches. COVID supply snarls in 2020? Gunsmiths nationwide fired them up for AR lowers and Glock frames, holding Sami specs as titanium chips piled waist-high. 80 years on, they're still cranking in makerspaces, outlasting 3 generations of operators. Contrast that ironclad endurance with the Haas VF2's whimpering demise. That $120,000 rig boasts ceramic bearings and 30,000 RPM spindles, but field data from a Nebraska job shop paints the obituary. 3,800 hours in, a Midwest thunderstorm's power flicker overloads the servo amp. Encoder loses steps and the Z-axis slams home. $12,000 spindle swap. Ball screws, those vaunted anti-backlash marvels, demand clockwork greasing every 1,500 hours. Skip it amid labor shortages, and fretting corrosion adds 0.005-inch slop, ruining die cavity molds. The epoxy granite base cracks under a dropped 50-pound vise, harmonics turning a facing pass into a wavy mess. Software seals the coffin. The Fanuc Zero-i controller, hyped for seamless integration, freezes on a G-code macro during a firmware OTA update in 2018. Part batch scrapped, $40,000 lost. John Deere's 2022 John Deere Operations Center fiasco stranded 8R series tractors mid-plow. Emissions software update demanded dealership recode after 2,000 hours, locking out regen cycles and rotting crops in Iowa fields worth millions. Bridgeport laughs. No ECU to hijack, no cloud subscription expiring mid-cut. Structural echoes abound. The 2021 Surfside Champlain Towers collapse. Inferior lightweight concrete with corroded rebar buckled under decades of salt air and minor quakes, paralleling CNC frames of thin-walled aluminum extrusions that bow 0.015 inches under thermal gradients from 120-degree spindle heat. Boeing 737 MAX MCAS software. Overrode pilot inputs twice, dooming 346 lives off Indonesia and Ethiopia. Blind faith in algorithms over Newtonian physics. Modern mills mirror it. Sensors detect vibration anomaly. Halt the job. Demand a $5,000 service call. Old iron powers through, mass converting energy to harmless sway. We abandoned this path for cold calculus. Post-Korea, labor costs for hand-scraping dovetails soared, 25-hour in 1955 bucks, while early NC controls from MIT's Servo Mechanisms lab let one foreman oversee 20 heads. By 1975, Mazak's Fusion 6400 slashed setup from hours to minutes, boosting throughput 500%. OSHA's 1970 Dawn mandated chip guards, e-stops, light curtains, ballooning prices 300%. EPA's Clean Air Act choked Meonite foundries with particulate traps. Last U.S. pours shuttered in 92. Globalization offshored castings to China, where sand quality varies. Damping ratios plummet 40%. Planned obsolescence grease the slide. Haas advertises next-gen yearly. Obsoleting controllers after 5 years. Proprietary ASICs fail predictably, extracting $60,000 upgrades. Bearings. Ceramic hybrids rated 10,000 hours, but real-world coolant contamination halves it. Shareholders feast on 25% margins from lighter 3,500-pound machines shipping via flatbed, not railcar, until the first harmonic resonance snaps a $15,000 tool holder mid-air cut. Safety theater abounds, redundant encoders and collision detection software, yet ignore fundamentals. Inertia trumps code every time. We prioritized pixels over pounds, velocity over virtue, and now watch $200,000 machines crumple under workloads a Bridgeport devours for breakfast. Through it all, wars cold and hot, recessions deep and shallow, floods biblical, these mills endure, their castings whispering defiance against the disposable age. Today, in 2024, you can find these Bridgeport Series I mills scattered like grizzled veterans across America's industrial underbelly. Walk into any serious prototype shop in Silicon Valley, say a SpaceX overflow vendor in Hawthorne, and there's one humming in the corner, fresh from a cosmetic restoration, milling rocket nozzle test fittings from 17-4 stainless, while the $250,000 Okumas gather dust from control glitches. Gunmakers in Cody, Wyoming, rely on them for custom 300-win mag actions, the table slick with decades of Cosmoline, cranking out barrels that thread true to one 100,000-inch runout. Vocational high schools from Tulsa to Buffalo keep fleets alive, teaching kids the feel of a fly cutter taking 0.0 on 10 inches per pass, no simulation software needed. Museums honor a few. The Smithsonian's National Museum of American History displays serial number 147, the one that machined the Enigma codebreaker's precision gears in a secret Long Island bunker. Canada's McMichael British North American Aviation Collection houses a wartime survivor, its overarm scarred from P-47 Thunderbolt cowl prototypes. But most aren't polished relics, they're workhorses. Online auctions like Machinery Trader list them weekly. 1939 Bridgeport, runs sweet, $4,500 OBO, bought by fabricators prototyping EV battery trays or wind turbine hubs, where the iron's thermal stability trumps flaky servos in dusty solar farms. Even abroad, they've infiltrated. Eastern European tool rooms, starved of parts for Soviet-era junk, Frankenstein them with Chinese spindles. But the frame endures, damping vibrations that trash imported Tormacs after 500 hours. A Brazilian diesel rebuilder emailed me last year. Pulled one from a São Paulo flood zone, baked it dry, and it's profiling Cummins camshafts for ag tractors hauling soy across the Pantanal. Mud, heat, zero mercy. Scrapped? Sure, thousands met the torch in the 90s consolidation wave, when CNC salesmen promised the moon. But survivors number in the tens of thousands, per the Bridgeport alumni registries, job shops, restoration yards, even NASA skunkworks. One in Houston machined ISS docking ring prototypes post-Columbia disaster, its quill dropping collets without the encoder drift that plagued coordinate measuring arms in climate-controlled labs. Stack that against the latest disposable darlings. DMG Morris's vaunted NLX 2500Y, $180,000 entry. Toots AI predictive maintenance. 6 months in a Texas oilfield shop. Dust from fracking sand infiltrates the scales, false triggering shutdowns every 200 hours, costing $2,500 calibrations. A 2023 uptime study from a Cincinnati integrator. Average lifespan. 7.2 years before frame resonance from hollow castings induces 0.008-inch axis errors, mandating $90,000 overhauls. Makino's IH500 horizontal. Vaporware promises after a coolant pump recall in 22. Plastic impellers shredding under cavitation, stranding aerospace contracts mid-run. Agriculture bites hardest. Case IH's 2023 Magnum 340 tractor lineup, $450,000 behemoths with precision ag telematics that bricked nationwide after a cyber attack vector in the CAN bus. Halting plows across the Corn Belt while yields browned. Echo's Case's own 2019 outage, software forcing limp mode after 1-800 hours. Dealers charging $15,000 remaps. Bridgeport? Parked through it all, ready when the grid flickers. Infrastructure crumbles in parallel. The 2024 Baltimore Key Bridge span collapse. Oversized container ship shears through supports built with high-strength, low-mass steel, thinner sections corroding faster under Chesapeake salt, lacking the ductile overbuild of WPA-era trusswork. Modern CNCs ape it. Optimized topologies from FEA software prioritize weight savings, but first thermal cycle bows the gantry 0.020 inches, amplifying cutter deflection into scrapped titanium forgings. We quit the old way because the bean counters won. By 2000, a hand-scraped Bridgeport rebuild hit $18,000 in skilled labor. Immigrants with rasps earning 60-hour, unions blocking automation. Fanuc's 31i controllers slashed oversight to 1 tech per shift, margins juicing to 35%. Dodd-Frank regs post-2008 hiked liability insurance for obsolete, unguarded mills 500%, pushing fleets to auctions. China's Ningbo foundries pump out Bridgeport clones at $8,000, but porosity in the castings drops modal frequencies 25%, chattering finishes on first overload. Obsolescence is engineered. Herco's VMX42i embeds RFID tags expiring after 8 years, locking probe cycles unless renewed at $7,500. Spindles? HSK63 tapers with polymer retainers that creep under sustained torque, failing at 4,500 hours, versus the old NT40's 50,000. Green mandates force lead-free alloys, embrittling ways under cyclic loads. Speed demons like 50-meter min rapids thrill demos, but without tonnage, inertia spikes fracture endmills mid-air cut. Safety theater peaked with ISO 232 vibration specs. Modern mills pass lab tests but fail shops without $50,000 isolation pads. Old iron needed none. Its belly laughs at harmonics. We swapped certainty for convenience, mass for metrics, and now face reshoring pains. TSMC chip fabs delay, stranding Haas fleets without encoders, while gray ghosts crank unobtrusively. So here we stand, 8 decades on, with these mills outlasting empires of code and composites. They're the last bulwark against fragility, proof that progress exacted a toll in forgotten tolerances and brittle bones. We gained velocity but lost virtue, the brute poetry of metal that bends but never breaks. Next time your Haas glitches, glance at the corner relic. She's not nostalgia, she's the invoice for our hubris, still cutting true while the future falters.